So we want to begin by taking a look at the two different forms of the quadratic we might actually see. We might see the standard form of a quadratic, which is ax squared plus bx plus c equals 0. Or we might see vertex form, which is y equals a times x minus h squared plus k. Now, from both of these, we can determine quite a few things, and that's characteristics. Alright, and these characteristics are, we have a y-intercept, which we'll talk about these definitions in just a second. We have an x-intercept, which is also referred to as zeros or roots or solutions. These are a couple different names you might see associated with x-intercepts. We have a max slash min. We have a vertex. We have an axis of symmetry. And then we have domain and range. Now, a y-intercept, it's real simple, it's easy. This is where the graph intersects the y-axis. X-intercept, zeros, roots, solutions. These can deviate a little bit. Roots, because roots, zeros, and solutions can be imaginary, but more specifically, x-intercept is where the graph intersects the x-axis. Max or min, this is the lowest, well, since we did max first, highest or lowest point on the graph. Vertex is the ordered pair at the lowest or highest point. Axis of symmetry, this is the line that divides the parabola into two equal sides, into two symmetric sides, sorry. Domain and range, domain is left to right, and that's how far left to right a graph will go. Range is how far down to up a graph goes. Now, from standard form, some simple things you can find. Your x-intercepts and y-intercepts are real simple. The easiest way to find a y-intercept is to substitute 0 in for x. Okay. Once you substitute the 0, so we'll practice one. Here's just a small problem here. Y is equal to x squared plus 3x plus 2. If we were to substitute 0 in for x, we would get 0 squared plus 3 times 0 plus 2. So if we work this out and perform the operations, we wind up with y equals 2. So our y-intercept would be 0, 2. Intercepts are ordered pairs, so we have to look at that whole pair. The next thing we can find from standard form is we can look at, if we were to graph it, we could look at domain and range and look at that graph. But zeros slash x-intercepts are another easy thing we can find from standard form. Since y-intercept was substitute 0 in for x, to find the zeros, we're going to substitute 0 in for y. Okay. Now from here we get 0 equals x squared plus 3x plus 2. Well, since we have a trinomial, we want to factor it. And the way you factor it is you split it up into two binomials, x in each one. And then since it's plus plus, we know that's going to be plus plus. And then what are the two factors that go into 2? Well, we got 1 and 2, so 1 and 2. Now, from here you have it factored. You want to set up two separate equations in order to determine what the two zeros are. So we subtract our 1. So basically it's just solving linear equations here. So we've been through this before. So we subtract our -1, we subtract our -2, and we notice our two zeros are going to be x equals -1 and x equals -2. Now from here we can move on to the vertex form. So for vertex form we can find quite a few other things. So vertex form, y equals, I'm going to go ahead and give us a problem, 2 times x minus 3 squared plus 4. First thing we can find is the vertex. Okay, vertex is HK. So if we refer back to our equation, I'm going to write it here at the side so everybody can see it. H is on the inside, K is on the outside. Now, this is automatically minus. It's x minus. That's part of the formula. So even though this says minus 3, this isn't going to be -3. It's always the opposite. So that's 3 and 4. So a quick thing to remember is that anytime we're working inside of parentheses with quadratics, your answer will always be the opposite of the sign you see. Okay, so there's our vertex. Our axis of symmetry. An easy way to remember axis of symmetry is x equals h. So in this case, since our h is 3, we know our axis of symmetry is x equals 3. Alright, the next one we can do is max or min. Easiest way to determine a max has a negative leading coefficient. Okay, min would have a positive leading coefficient. So in this case, we take a look at our leading coefficient. It's 2. Alright, so that means it's a min. So this is going to be a min at, and then it's at k. So in this case, instead of putting a k here, we're going to say a min at 4. Alright. Next thing we can identify is we can identify the easy things to identify. We can easily identify domain. Domain we can identify for both. The domain of any y equals quadratic is always going to be -infinity to infinity with parentheses, because we can't equal infinity, because you can't equal every single number at once. Now from this we know this is because is there any x value that I put in here, will I always get an answer? So basically, if I input something, will I always have an output? And yes, you do. Range, on the other hand, if this has a minimum value, that means that we can equal the minimum value, but are we going to go higher or lower? In this case, since it's a quadratic, it's going to keep going up, so that's infinity. And those are the basic things we can learn from vertex form. We can go even farther with this, but for now, this is where we're going to stop at, and we're going to do some practice problems.